Okay, I'm back for calculus, and I figured out what I did wrong here. I should have divided my 10 by 3 because it's a 3 by 4 grid. And so my length I divided by 4. My width I should actually divide by 3 because it's a 3 by 4 grid because there's 3 of these by 4 of these. So that's why I would do that. And that gives me the right answer. Okay. Business. Section 6.8. Last section. We're going to do 2 examples, I think. So again, we're optimizing, but this time we're talking business. So usually when we talk about optimizing in business, we want to maximize profits, minimize costs, those types of things, okay? So all those formulas about like revenue is price times the number that you sell, and profit is your revenue minus your costs. All those are going to come into play. So example 1 says that market research. Oh, I hate this example, but I'm gonna do it, but I'm gonna change it just a little bit because I would never ask the first part of this question. Market research has shown that for every drop in price of a product, there's usually an increase in sales. That makes sense, right? They drop the price of something, and so you end up selling more. Similarly, an increase in price usually leads to a decrease in sales. A large retailer selling mountain bikes has found that for every $20 that they reduce the price of this particular bike called the Rockhopper, they sell 2 more bikes every month. This bike usually sells for $900. And at that price, the store sells 50 bikes per month. So, I would not ask you part A. I would actually give you part A. So let's talk about what part A is. Part A says determine the optimum selling price in order. Well, actually, I would ask you A, but not any. I'll get there. Determine the optimum selling price in order to maximize revenue, and how many bikes are sold at that price. Okay, so in part A, it says the problem requires us to maximize revenue. We want to maximize our revenue, which makes sense. We want to maximize the amount of money coming in. Revenue is the number that I sell, so X, the number of items that I sell, multiplied by the price. So if I sell 20 of them and I sell them for $50 each, 20 times 50 would give me my revenue. The thing is, they don't give you a formula for the price. They expect you to come up with it. I'm never going to do that. I'm going to give you the formula for price. Okay? So that being said, okay? So that's why I say I would never ask you the first part. And the first part, you have to come up with a formula for price. I'm never going to ask you to do that. I'm just going to say the formula for price is. Okay, so they figure it out. Doesn't matter how they do it because we don't care. I'm just telling you that the price formula they come up with is negative 10x plus 1400. Okay, that is the formula that they come up with. I'm never going to ask you to come up with that. They come up with it. But if that is the price formula and we want to maximize revenue, If you want to maximize something, you need to take the derivative of it. So the first thing we need is we need a formula for revenue. And revenue is the number that I sell times the price. And the price is negative 10x plus 1400. That would be given to you. Okay, so revenue then is negative 10x squared plus 1400x. Now, if I want to maximize this, I need to take the derivative of it. And so that's going to be negative 20x plus 1400. Then I'm going to make it equal to 0. Negative 20x plus 1400. And so 20x is equal to 1400. And so x is 1400 divided by 20, which is 70. So if I sell 70 bikes, that's where I'm going to maximize my revenue, okay? Part B says, describe the shape of the graph. We're not going to do that. Oh, and it says, determine the optimum selling price. Determine the optimum selling price. Well, if I maximize my revenue when I sell 70 and the price is negative 10x plus 1400, then the price is negative 10 times 70 plus 1400. So my price is negative 700 plus 1400. So the price is $700. So I'm going to maximize my revenue when I sell 70 bikes at a price of $700 each. At the beginning, they said usually the price is $900. So I know if we want to maximize our revenue, we need to lower our price to $700. That will maximize the amount of money coming in. This is an actual job that people do. It's called a business analyst, where they come in and they do things like this to figure out things like what price should we sell it at, how many should we make, how many employees should we have, how do we minimize costs, how do we maximize revenue. There are people who do this for a living, okay? We're not going to discuss the whole describe the shape of the graph. We don't care, okay? Because we're not going to be graphing in this. So you need to remember those formulas that I gave you in another chapter. Can't remember which one it was now. Oh, I just opened up to it actually. It would be, nope, sorry, not there. Chapter 5 maybe? Nope, chapter 4, where we talk about rates of change in social sciences. Section 4.7 actually, and we talked about the fact that revenue is the number that you sell times the price. Cost will always be a formula given to you. Price or demand, same thing. That will always be a formula given to you, but profit is your revenue minus your costs, because it's the money you have coming in minus the expenses that you have to pay out. Okay, profit is, it would be the same thing in your personal finances, right? If you want to figure out how much money is your profit after your pay, how much you actually have to spend on the things you want to spend on, you subtract all your expenses like rent and food and taxes and all of those things. And once you take off all of your bills, all of your expenses, whatever you have left is your profit, what you can save or spend on things you want or whatever you decide to do with it. That is what you have left over to play with. All right. So if you're questioning those formulas, page 389, the bottom of it in blue. The last example we're going to do is example number 2. Example number 2 is much longer looking. It's not going to be that much longer. And we're going to do A and B. We're not going to do C. So the beverage industry in Canada produces over $10 billion worth of product annually. Based on a 10-year study of production costs, wouldn't you want to have to perform that study 10 years? A winery in the Niagara region has determined that the cost of producing X number of bottles of wine is $12,000 plus 4x plus 0.0002x squared. That is the formula for figuring out the cost associated with making a certain amount of wine in this case. Market research shows that the demand, or the price for the wine, is given by the price function, always a little p for price, is 12 minus 0.0001x. I think I have the right amount of zeros there. 1, 2, 3. Yep. Now it says determine the production level. So determine the x value. Determine how many bottles of wine will maximize my revenue. So the first thing you have to do is figure out your revenue formula. And revenue is the number of bottles that I make multiplied by the price. So my revenue is 12x minus 0.0001x squared. So if I want to maximize my revenue, I take the derivative, which is 12 minus 0.0002x, and I make it equal to 0. So I'm going to move this over, and I'm going to have 0.0002x is equal to 12, and I'm going to divide this by 0.0002. I'm going to divide this by 0.0002, and I'm going to get that x is 60,000 bottles of wine. So if I want to maximize my revenue, my money coming in, I need to make 60,000 bottles of wine. Now that doesn't necessarily mean that I'm maximizing profit, because just because I maximize the amount of money coming in, maybe my expenses are really high at that point and it might not maximize my profit. Okay? So the next one says determine the production level that maximizes the profit. Okay? So we just figured out that the formula for revenue is 12x minus 0.0001x squared. That was my formula for revenue when I figured it out. Not the derivative, just the formula for revenue. So if I want to maximize profit, I actually need to figure out the formula for profit. And profit, big P, is my revenue, the money coming in, minus my costs, the money going out. So profit is 12x minus 0.0001x squared minus the costs, which is 12,000 plus 4x plus 0.0002x squared. So when I figure that out, my profit, remember I'm subtracting these, is negative 12,000 plus 8x, because I have 12x minus 4x, and negative 0.0001x squared minus 0.0002x squared is minus 0.0003x squared. So that's my formula for profit. Now I want to maximize profit, so I'm going to take the derivative. So the derivative of 12,000 is 0. This would be 8. I'd bring my 2 down and I'd have minus 0.0006x. Okay, and then I'm going to make that equal to 0 and solve. So I'm going to have 0.0006x is equal to 8. I'm going to divide this by 0.0006. I'm going to divide this by 0.0006. And x is going to be 13,333. Notice that it's a very different production level in order to maximize profit. Just because I maximize revenue doesn't actually mean I'm making money. I could maximize my revenue and still be losing money. Because at this production level, maybe I have a whole lot of money coming in, but maybe I have a whole lot of expenses too, and I could actually end up losing money. I'm better off to stay here, stay smaller, and only make 13,333, because at this I'm going to maximize the actual amount of money I get to put in my pocket. All right. So that's it. That's what you are, that's this section. So I'm going to give you very few to try in this section, and we will be done chapter 6. Again, for Thursday, I will do a review. I will answer any questions that you leave for me. I've already answered a couple out of section 6.7, but like I said, only a couple of people had submitted their homework at this point. So if there's more, I'll answer those. And then if there's any on 6.8, I'll answer those. But I will make a video tomorrow reviewing chapter 6. Friday is a day off. I'll make Monday a study, answer question kind of day. And then test will be Tuesday, May 12th. So you have almost a week's worth of notice. Lots of time. All right? So that's it. I will do a review tomorrow. See ya.